Next section in our geometry unit is area of composite figures. We've now worked with finding area of several different shapes, and we've also focused a lot on circles. So hopefully today you have all the knowledge regarding the formulas to help find area of composite figures. So by the end of this lesson, you'll be able to find the area of composite figures and also solve problems that involve the area of composite figures. So the vocabulary term is composite figure, and a composite figure is a figure that's made up of two or more shapes. When we find the area of a composite figure, we're going to decompose or break up the figure into shapes with areas that you know how to find. So if you look below at that shape, it might not be obvious to you at first what different shapes there are kind of hidden or that make up that figure. And there's also more than one way you can break up a figure. My tip to you is to just do it in the simplest method. So if I look at this figure, I don't have a formula for the area of that figure, but I do see a couple of shapes. The first shape I see is this circle here at the top, and it's really more like a semicircle or a half of a circle. So if I draw kind of a dotted line and then I trace this outer part in red, you can see that half of a circle. But now I have a shape here that has a couple of right angles, and if I extend all the way down and draw a dotted line here, I see a rectangle. So now I have half of a circle, and I can find the area of a circle and then just cut it in half. I also have a rectangle, and now you'll see a triangle. So there are three shapes there, the circle, the rectangle, and the triangle, and you do know how to find the area of all of those. So you could find the area of the entire figure by adding them together. So let's review our area formulas. Area of a parallelogram is base times height. Area of a triangle is 1/2 times the base times the height. Area of a trapezoid is half of the height times the sum of the bases. And remember that the bases of a trapezoid are like the top and the bottom piece. And then area of a circle is pi r squared. You should already have these in your notes from our area lessons and our circle lessons, but if you want to jot them down again, you can do that. So let's find the area of this composite figure. It looks like a giant arrow, and you can see that I've kind of already split it up into its different shapes, a rectangle and a triangle, so that we can see different dimensions also drawn in so that we can find the area. So first let's start with the rectangle, and I'm going to use a little RECT here next to the A for area so that we know it's the rectangle. Area of a rectangle is length times width or base times height, so 15 times 23. Those are the dimensions of the rectangle. So we would do 15 times 23, and that's going to give us the area of the rectangle. Let me get my calculator. So that's 345, and we want to make sure we have our units. It's 345 inches squared. All area is squared. And now we have the triangle. And I'm just going to write the word try there so we know that that's the triangle. Triangle is 1/2 times the base times the height. So we need the base of this triangle. So that's kind of this bottom part here as I draw my pen through it. And here you have to kind of look throughout the figure because no one tells us exactly what this long length is, but you can see that this little side here is 6 inches. The middle we're not given, but because this is the rectangle, we see that it's 15 down here, so this is also 15. So we have 6, 15, and 6. So if you add those together, 6 plus 15 plus 6, you get 27. So the base of that triangle is 27 inches, and you can see the height of the triangle is 8. So now when we multiply 0.5 times 27 times 8, you get 108 inches squared for the triangle. Now for the area of the figure, it's 345 plus 108, 453 inches squared. And don't forget your units. Let's look at another example. Find the area of this composite figure. Hopefully here you can see the two shapes. We have like kind of like an upside down ice cream cone, it looks like, or maybe a teardrop or a raindrop. But you see the cone portion is the triangle, and then we have this half circle down here at the bottom. So we want to find the area of two parts. We have the area of the triangle, and that's 1/2 times the base. So the base of this triangle is 6 meters times the height of the triangle, which is 16. So 0.5 times 6 times 16 is 48 millimeters squared. Oh, actually, let's just make that a meter. Looks like I put meters here and millimeters here, so let's just make it meters. So 48 meters squared. So now then we have to find the area of the circle, and we'll remember at the end that we need to cut it in half. So area of a circle is pi r squared, and I'm just writing that there so we can remember. So we have pi times the radius squared. Now be careful here, this is not the radius, this is the diameter, so we have to cut that in half and get 3 and square it. So if we do pi times 3 times 3, or pi times 9, we get 28.2743. That should be enough decimals for right now. But now we need to cut that in half because this is just half of the circle. So we divide that number by 2, we get 14.14. If I round to the nearest hundredth, I note in the directions it doesn't say where to round to, but we'll just do the hundredth for now. So that's meters squared, and we need to add that to 48 to get the area of the figure. So it's 48 plus 14.14, and that's 62.14 meters squared. Finally, let's look at kind of a story here. We have a ceiling tile, or we're told that a ceiling tile covers 3 square feet. And we need to know how many tiles are needed to cover the octagonal or octagonal ceiling shown. So we know that it covers 3 square feet, and we need to know how many tiles we need if we have a ceiling that looks like this. So first what we need to do is find out what the area of the ceiling is. So it is an octagon shape. You see it has 8 sides, and it's been split up where you can see this rectangle shape in the middle, and then you can see a trapezoid at the top and at the bottom. So let's first find the area of the rectangle of the ceiling. So the area of the rectangle would be 18 times 20. So that's 360 feet squared. And now we need to find the area of the trapezoid. And that's this shape here at the top. Notice there's also one at the bottom. So once we find the area of the trapezoid at the top, we'll just multiply it times 2. So the area of the trapezoid is 1/2 times the height, and you'll see that the height of the trapezoid is 5 feet, times the sum of the bases. So the top base of the trapezoid is 10 and the bottom is 18. So it's 10 plus 18. So you're doing 0.5 times 8, or excuse me, 0.5 times 5 times 28. The sum here is 28. And that's going to give you 70, but we need to multiply it times 2 because there are 2 trapezoids that we've cut out of this, the shape of the ceiling. So that's 140 feet squared. So if we find the area of the entire ceiling, that would be the rectangle plus both of the trapezoids. So that's 360 plus 140. That's 500 feet squared. And now we're told that one ceiling tile covers roughly 3 square feet. So if we take 500 and we divide it by 3, that will give us roughly how many ceiling tiles we're going to need to cover the ceiling. And you get 166.6 repeating, and since we're going to assume we've got to buy the entire ceiling tile, we're going to change this 167 tiles are needed. So we were able to find the area of this shape because we could break the octagon up into trapezoids and rectangles, find the areas of each of those pieces and add that together, then divide it by 3 because we're told that one ceiling tile covers 3 square feet. So we were able to find the area of the composite figures in examples 1 and 2, and also we solved a problem that involved the area of composite figures in example 3, and we'll work on our area of composite figures worksheet in class.